Given a non-negative integer x, return the square root of x rounded down to the nearest integer. The return integer should be non-negative as well. Alright, seems pretty easy. We can just raise it to the power of 1/2, but then cast it to an integer. Let's just double check the question, because it can't be this easy.
2 seconds later. 1 eternity later.
Alright, so I guess this works, but it's pretty much a very brute force method. But essentially we're just taking all numbers from 0 to x, x inclusive, so we can cover like 0 and 1. And then we're just seeing if that number squared is equal to x, we just return that number. Otherwise, if that number squared is greater than x, we just return that number minus 1 because we want the floor of the square root. And then we're using long here actually prevents the integer overflow error we get if we just use int. But yeah, actually just returning 0 here is also beneficial because we could literally just do this. We could just do 1, and then that way this will actually cover the case where it's 0. And this time complexity is pretty bad. It's pretty much going to be O of square root of n because, well, it would be like worst case O of square root of n plus 1, but because we're essentially looping through it all the way until 1 greater than the actual number. Alright, so the solution is essentially just binary search. So its time complexity will be O of log base 2 of n, but the base doesn't matter too much, so it would just be O of log n. And this is much more efficient than the previous solution. And then so for space, it's like constant space.